So yeah, welcome everybody to today's session on the impact of research misconduct and on correcting the scholarly record. My name is Jördis Česnik. I'm your chair, and we have 4 talks. I would say it's quite a colorful range of topics that we have today, both on research misconduct, but also on the prevention, on the detection, and then later also the correction of research misconduct. And our first speaker is Daniel Pizzolato. Daniel works at UEC currently, the European Research Ethics Committees, and is also associated as a postdoc with KU Leuven. And Daniel has a background in bioethics, but also in the chemistry and pharmaceutical technology, so a little bit interdisciplinary. And you have been involved in diverse EU projects on research integrity, and are now basically working full-time in research integrity and research ethics. And Daniel is presenting a review of literature on actually the impacts and consequences of research misconduct. So looking forward to your talk. Okay.
Thank you, everyone. Thank you for the introduction. Welcome to this session. Okay. So my presentation will focus on a review I have done together with my colleague, Dr. Rodriguez from Trilateral Research, about the adverse impact or the consequences of research misconduct. This is a brief outline of the presentation, small introduction, aim of the study, the methodology we have used for the review, and then the focus of the presentation. Socioeconomic impact of research misconduct, mitigation measures, and I will conclude with some general recommendations on how to possibly avoid research misconduct and all the consequences. So since I found this picture, I use it as a kind of, everyone knows what we are talking about. This is a kind of Dante-like representation where at the top you have responsible research practices, in between questionable research practices, and at the bottom where is freezing here, research misconduct, falsification, fabrication, and plagiarism. Usually we are used to see on the newspapers or on the television the spectacularization of cases of research misconduct, but also there are other consequences. There are more, let's say, tangible consequences, like having 172 papers retracted or being asked to resign as a ministry, or simply being kicked out from your institution. But also there are intangible consequences. One of them is just about trust in science, trust in researchers and among researchers, trust in funding agencies. The aim of the study is to give an overview of all the possible consequences of research misconduct, an overview of the affected stakeholders, an overview of the possible mitigation measures, and to provide some general recommendations. This is the methodology we have used. We search peer-reviewed literature and gray literature on the topic, but also we had a small round of consultation with experts to see if we have missed something during our search. All the consequences we have gathered during our review were included in this 7, I think, clusters about trust, about education, careers and employment, business and investment, health and well-being, research, standards, regulation and policy, and publishing. Let's start from trust. So what are, in terms of trust, the main consequences of research misconduct, but also of questionable research practices are damage to trust in science and research and researchers, distrust in healthcare, negative impact on forensic reports, opportunity cost of loss of trust by public, and damage of the reputation of labs or institutions or universities, but also adverse impact on the presupposition of innocence of researchers. Education, one of the main consequences is about misinformation, not just in medical literature, but in literature in general. And these can have consequences or on follow-up research or follow-up studies, not just in relation to well-being and health, but also in relation to social sciences or chemistry or other scientific field, but also adverse impact on education budget. Careers and employment. Usually when we think about consequences of research misconduct, we think about the researcher who committed malpractice. But it's not just about having a negative impact on the career of the researcher, but also negative career impacts for whistleblowers. And no one usually is thinking about, okay, what about the collaborators? It's not just about having papers retracted. It's also about having labs shutting down and people losing their job as researchers. Competitive disadvantage for researchers who abide by the rules. So usually, if you are not get caught, you can have your publication in the highest impact factor journals. You can be excluded from grants. You can have of course you can have increased research misconduct controls, and I think it's a good idea, but also risk of stigmatization through false positives. Sorry, business and investment. Financial cost of the investigation. You have to put money on the investigation process. Costs of remediation of misconduct. If you have to do again and again and again a study, because the first one was not really done properly. Financial costs for funding sources. Serious implication for the scale of discontinuing public investment. Significant direct financial costs to funding agencies and research institutions, but also an increase in litigation and legal costs. Health and well-being, so negative impact on individual well-being, about preventable illnesses, loss of life, anxiety and fear, negative effect on patients, public health and safety, on prescribed medical care, financial consequences for the health system, and indirect costs to the society to belief in false results and misinformation and harm to environment. Research, negative impact on the ability to reproduce or replicate studies, but also, for instance, negative effect on the participation rates in studies. If you don't have people participating in your study, especially within the social sciences, you cannot have your research done. Direct damage to science, negative impact on translational research and other disciplines, and also distortion or damage to the research. Standard regulation, simply misinformation and deception of policymakers. Adverse impact or undermining of government's ability to foster and promote research in a competent and responsible manner. About publishing, retraction, financial costs resulting from retraction of scientific papers, increase of peer review, loss of editorship, decrease in new articles. These are some of the different consequences of research misconduct and questionable research practices. But what are the impact drivers and what are the affected stakeholders? Within the impact drivers, lack of supervision. There are studies in which lack of supervision lead supervisees to take shortcuts. Inadequate training, competitive and career pressure, personal circumstances. You need to publish because you don't get renovated your visa. Individual psychology or self-control issues, but also low or lack of deterrence. And what are the main stakeholders affected? Usually we think about, okay, the researcher, the institution, but also administrators, collaborators, educators, funders, research participants, or students, or the society as well. So those are some of the main affected stakeholders that can have an impact for the consequences of research misconduct and questionable research practices. And these are some mitigation measures we have found within the literature. There are preventive measures to prevent or reduce potential impact before it occurs, corrective measures to reduce the impact to an acceptable level. Okay, it's not the best option, but still it's something, but also compensatory measures that are applied when there are to fail and to compensate for unavoidable harmful impact. Those are some of examples of preventive measures, awareness measures, clear authorship criteria, detailed protocol writing, good scientific practices, corrective measures, for instance, correcting scientific records or fines, sentences, criminal sanctions, mentoring and oversight, but also there are compensatory measures, policy interventions, pressure reduction measures, public education, training, whistleblower counseling. Those are some of the mitigation measures can be introduced by institutions and by policymakers in order to avoid research misconduct. And what can be the main general recommendation to avoid these consequences and to avoid research misconduct? These are just some overarching themes on how institutions, policymakers, funders, publishers can implement to avoid the consequences, to avoid research misconduct and questionable research practices. Promote a culture of integrity training, data management and transparency, responsible authorship, mentorship and role modeling, and so many more in order to avoid as much as possible, not just possible consequences, but just to, let's say, eradicate research misconduct and questionable research practices within the research environment. Thanks.
Oh, you can stay there, Daniel. Thank you for this great talk. Do we have any questions from the... I hope so. Do we have any questions from the audience here? Oh, this should work. Or online? I don't see a raised hand. I do have maybe... Oh, we do have one.
Could you say a little bit about which gray literature sources you were drawing on and how they were collected and how they were identified?
Sorry, I didn't really... Sorry? Okay. Okay, at the beginning, we tried with the Google search, but was not really working. So at the end, we went through all the main, let's say, document policy recommendation we have found online from UNESCO website, from ENRIO website, from other European Union website. So these are the great literature we gathered. We also gathered information from previous European funded project on this topic. So this is the main great literature. As I said, we tried with a Google search, but was not really working, was too generic. So we decided to look specifically to specific website to see if there were some online recommendations, documents, or policies about the topic, and not just within the peer-reviewed literature.
The question.
Marusic, Split Croatia. I want to ask you, because you talked about, economic impact. Is there any literature or data on how much all of these interventions cost? And I come from medicine, and we're going to have health technology assessment as a regulation in EU. It will become mandatory, where you have to show clinical effectiveness and then look at legal, economical cost-benefit analysis. How much all of this costs? Especially I'm talking from a position of a small journal editor.
Mm-hmm.
For us to implement all of the studies to correct literature, it's enormous cost for which we don't get funding. It may be easier for big publishers, but not for us. So, yeah, are there any studies on how much this costs, and then what is the
there are studies on how can cost to publishers, editors. I don't remind by heart the exact amount of money, but also there are studies about how much money a single researcher can pay as a fine after getting caught about these practices. So there are studies out there. And of course, these studies are at this amount of money are very much depending on the country, because also depending on the legal system within the country and if there are specific procedures.
Almost have to move on, but I have one little question, because there are so many secondary effects I want to say that you found. Was there anything where you would say this could even, difficult wording, but a kind of a positive side effect, because it was such a long negative list, such as it stimulates policy making? Was there anything surprising that you found?
Of course, there are also, we can call them positive consequences, like institution implementing trainings or implementing policies or implementing support for supervision or for trainers. Also, there can be increasing the level of or the transparency of peer review. Mm-hmm. So there are positive consequences, even though, it's not, also, even though these positive consequences or corrective measures should not be the last option.
And now our next topic, or our next speaker is Frederique Bordignon. Where are you actually? Over there. Frederique is from France, from the École des Ponts, Université Gustave Eiffel. Your background is linguistics, but now you present actually a different topic. You have conducted a study in the field of research integrity. Also, you've been involved in research integrity as a trainer in the Virtual Project, just to give some of your background. And you have conducted a study amongst chemists on how they perceive misconduct and are correcting it or not.
So thank you. So I'm going to talk about correction of science, drawing on a survey among chemists. And I'm going to start with the first question: what is correction? So I think we feel like correction is a good practice, a process of improvement, because we think we are going from false to true, from not correct to correct. So we have experienced correction at school, of course, but also more recently, we have correction processes in sport with video assistance in football or challenges in tennis matches. Also, a lot of updates to fix bugs in software developments. Also in financial markets, we talk about correction of prices. So correction is valued as a positive behavior. And I think it draws on many virtues. I gave some examples. So maybe we can talk about transparency when we make correction, accountability, honesty, accuracy, when we correct something in order to be more accurate. But we can also talk about courage, whether it comes to correcting someone else's error or one's own error. So does it work? Yeah, I can't change my slides on my computer, sorry. So what is correction of science this time? So usually we think about two different kind of correction when it comes to correction of science. First, the correction of the scientific record, of course, which is a very visible process with some people say we have a disruptive intervention into the record with the publication of an erratum, a corrigendum, an addition, a retraction. So it's something visible. We know that it takes time, too much time. It's not fully trustable because the dissemination of this information about a paper being corrected or retracted is not done properly. But there are also, on the other hand, more subtle processes that are incremental, less visible, maybe invisible, taking place between researchers. So what does that mean in terms of good practices to correct science, and what are the best behaviors to foster, to ensure correction of science? So I built a survey among chemists. Well, I can explain during the break about my methodology, but I got a bit less than 1,000 answers, which is not a very high response rate. But I had the chance that many of my respondents took time to leave a comment in free text fields I provided. So 40% of them give comments, and those comments were very important and very rich for the analysis. I know there are limitations in this survey. We can also talk about this, sample bias, cultural differences, and of course it's focused on chemistry only. But I think it's more interesting to talk about the results. So if you, I asked them if they have ever discovered a scientific error in a published article of which they were not the author, and the large majority of them say yes, 88%. And when asked those people if they did something, did they did something to correct or to attempt to correct the error that they face, the vast majority also say yes. And when I asked them if they have ever discovered a scientific error in a paper they co-authored or they are authored of, 50% say yes, 50% no. And when again asking whether they did take action or not, again, a large majority say yes, they did something. But the question is, what actions, what were their motivation, and what barrier they face? So analyzing the result, I think there are a wide range of actions. And first of all, actions on the scientific record with publication of editorial notices, of course, and mainly where the people are author of the paper to be corrected. But they also mention critical citations, either when they find an error and publish something else, they mention the previous work with a critical view, saying there is a problem in this paper and we think we can improve it that way. But even in their own paper, they make a kind of self-critical citation or critical self-citation to correct what has been published before. What we can see also that very, very few publish a comment on peer, or a letter comment or not to the editor, or a formal refutation. Very few also undertook replication projects, but those who did are those that more often agree that those actions correct science. So there are also another frequent response, which is private discussions between peers, mainly when the error is in someone else's papers. Of course, we prefer to talk about someone else's errors rather than own. This time, only 55% agreed that this contribute to the correction of science. And also what was more obvious in comments they left, they had discussions with students. They spontaneously present this as a pedagogical opportunity, either to talk about the very issue, the error to be corrected, or about the whole process of correction of science. And they also talk about their own experience facing an error and trying to correct it as an instructive experience. And what are their motivations? So the most frequent answer was, okay, as a matter of principle, if there is an error, it should be corrected. There is no, this is the very frequent answer, and their motivation is, first of all, to limit the propagation of the error and to act in favor of their own community for the good of the community they belong to. They also have concerns about the scientific consequences, and in the responses I have many, it depends. So it depends to what extent it changes the conclusion of the paper. Also, they face the failure to replicate. So they are working on the same topic as someone else, and then they find an error because they can't go further. They can't replicate the paper. So that's a motivation for them to talk about the error so that they can publish their own results in consistency with the rest of the literature. And also the propagation of the error can be detrimental to their work. So it means that if the error is still there, well, it's not easy for them to publish new results because there is still this confusion in the literature about the very same topic they are working on. And about the barriers to correction, when the respondents were author most of the time, but also when they are not the author, they talk about the fact that there is no scientific consequences. So it doesn't matter, well, there is an error, but it does not change the conclusion of the paper. Let's go to the next topic. But this is also very often related to time. Many respondents in the free text fields talk about time, lack of time. It takes too long. There are too many errors, with people saying, if we start correcting errors, well, we won't do research anymore. We will spend all our time correcting errors. They also mention editors a lot and problems with editors. During the peer review process, many complain about their own comments, and also the fact that the flagged errors are completely ignored by the editor. Sometimes they complain also about the reviewers they are reviewing with. They say they're lacking skills, they are not doing their job properly, and the editor is not doing his or her job properly to deal with that. And after publication, we knew that before that, but they also complain about editors being reluctant to take actions because of the bad reputation it could raise about their journal. They also mention a lot problems about social relationships and what I call hierarchy between peers. Even if they don't say it like that, they talk about big names, top scientists, people being too big to fall, powerful and connected. So they just don't attempt to correct, to do anything because they know it won't work because they are big names. They also talk to a very less extent to the fear too often callings to say, well, you made a mistake. But that's not a very frequent answer. So as a conclusion, what we can say is that there is no resistance to the correction of error coming from the scientific community. Of course, errors should be corrected, but it depends, and it depends on a lot of things, and it depends mainly on the types of errors. They use minor, major, obvious, big, serious, not serious, and so on. And it should also be easy to do and quick. But also what is very obvious in the results of this survey is that there is no call for sanctions, of course, as long as errors are honest, and almost everybody agree that making errors is part of the research process, but there is more incentive to do this correction, and they complain about all the obstacles to correct. And again, the editor is presented as the source of all evils, with many errors. I have a question on that. So they say that many errors are spotted during a peer review, but reviewers' comments are completely ignored. And that's why there are errors in published articles that need to be corrected afterwards. Also, a wide variety of actions are possible, but those affecting the scientific record are most often seen as better practices, more efficient practices for correcting science. So how to turn good intentions into practices? So first of all, to promote correction initiatives and present them as research integrity practices. Could be, of course, in research integrity training, courses, in codes of conduct. We talked about the ECOG. There is a paragraph dedicated to correction. In the media, when a journalist report retractions, for example, or how people corrected their own errors. Also in research assessment, why not consider corrections as contribution to be listed on CVs and on narrative CVs? I think it will fit well. And also a focus is expected on the record. During the peer review process, why not dedicate a field in the templates we use to make reviews for the reviewers to report, to flag properly and prominently an error, and with the possibility to explain how to correct the error so that the editor will see more easily there is a problem, there is an error, and it could be corrected that way, or it cannot be corrected sometimes. And post-publication, we need to raise the awareness among researchers, mainly those who have editorial responsibilities, to make correction processes more flexible. And with this kind of survey, we can show them that it is what the community, the scientific community, at least, to be honest, the chemist community is expected from them. Thank you.
Again, yeah, oh, we have a question.
Thank you. Thank you for a very nice talk and interesting results you're presenting. I am sure that you have thought about how specific to chemistry your results are, how they are, if they are general or if it's specific to that field. And then I was mainly thinking about this, how they deal with when they have discovered errors, like reporting them to PubPeer, etc. So I would like to hear your thoughts around that. Thank you.
Well, of course, I thought of that, but I have no material, no data to compare to, and that was, as you saw, it was very difficult to get enough answers to have significant result within the chemist community. So it means thousands and thousands emails to be sent to other communities to make comparison, but I cannot speculate more on that because I don't know. It was really focused on chemists.
I have a question. Have you published your results, or are you planning to publish it? So can we read it?
Not
again?
yet, but I'm planning to. Yeah.
Because I found it very interesting. Do we have other questions?
As a journal editor, I would like to point that also it's very important to keep indexing databases as a stakeholder, because my experiences in studying corrections is that they are indexed in very different ways in different databases. So for someone who is looking for information, they often don't see, depending on where they look, they will see or not see the correction to an error. And there are, PubMed, for example, has a whole taxonomy of different types of corrections they are making to literature, which is very important for journal editors because we want to ensure the integrity of the published record. So nowadays, it's not something that editors kind of shy away. And when you look at PubMed, the number of corrections and retractions has increased a lot. And it's not anymore a stigma for the journal to correct. I even think, and we're doing a study on, they overcorrect. Especially during COVID, I've seen corrections, they correct a spelling, they correct address number or something like that, which, what you said, I think it's very important that researchers always looked at how it affects the results and the conclusions. Yeah.
So actually, si vous pouvez mettre la dernière slide, there is a second part of this study, which is the assessment of how the JACS, which is a paper in chemistry, very famous one, a big journal, how the JACS handles those retraction and correction. And the last reference, I checked how the retraction is labeled in different databases. On the JACS website itself, it can be false, also at the publisher's website, and also the dissemination of this information in open access databases. Also, we can imagine people cannot access the JACS, the ACS has no ACS subscription and will use open access databases. And then the flagging of errors, retraction, correction is very, very poor, even actually invisible most of the time. So that's the second part of the survey, which I try to connect.
Looks like we don't have more questions. Yeah, thanks a lot for presenting this great study. And yeah, I think it's at least a great outlook that so many of your respondents are very willing to correct if it's quick and easy. With that, we go forward to our last talk of today, presented by Anna Marusic. Anna is a professor in the field of medicine at the University of Split School of Medicine in Croatia. And Anna has not only published a lot, but also has a lot of experience as an editor. Is also chair of the research committee of the World Association of Medical Editors, but also performs great research. And today you are actually presenting a study on how to train students, and if it's possible to train students to detect image manipulation.
Whether they can see image manipulation. Thank you very much. Thank you. Actually, this study was made from, kind of a point of a journal editor, because I remember, almost 20 years ago, and Mike Rosner from Journal of Cell Biology putting forward the first guidance on image manipulation, what you can do and what you can't do. And usually at that time, everybody says that if there is something wrong with the paper, how come that editors or reviewers didn't see it? Something is wrong. And we just wanted to see whether people can actually see a digital image manipulation. So I want to acknowledge my colleagues. These are all early career researchers, and we did a study on students because that's population for us to pilot and study things. So, and this is just kind of declaration. This is a research integrity conference. I have to declare my affiliations and activities that are relevant, especially the funding for the Croatian Research Foundation for this study. And of course, all of us can see some obvious things. You see that these are very similar bends on a gel. If you ask a computer, the computer will see something more. And now we have really advanced in classification and how we handle digital images and how we check it. If you go to the Office for Research Integrity, there is even like a forensic droplet that you can put down into your Adobe Photoshop and check what has been done with the image. This is a definition of image manipulation as a kind of misconduct in research. And there are different techniques. You can crop, you can color adjust, you can selectively enhance things, and you can duplicate things. And this is what was the focus of our study that I'm going to present something. And when you look at how prevalent is image manipulation, I remember that when we first started talking about digital image manipulation in 2004, Mike Rosner from the Journal of Cell Biology, who publishes a lot of images, said that it's about 2% of the accepted papers. They didn't test all the submissions. So they say that about 4% of the papers, that was, of course, everybody knows Elizabeth Bick and the Eagle Eye for image manipulation, that about 44% of all the papers had some form of image manipulation or a duplication. So when we talk about duplication, which is the focus of this study, this is kind of cloning objects into an image, and there are different types. So you have a simple duplication. These are all inappropriate image duplications. So you just take something and you duplicate it simply. You can duplicate and reposition. You can take it from one slide to the other and turn it around. And you can even have duplications within the same figure, as this example shows here. So what we wanted to see, because we couldn't find any studies, and you have lots of programs on our softwares that do this, and we have seen, for example, that those that are available in open access are not as good, they're not that much better than human eye. You have the professional ones for which you need subscriptions, that are probably better one. But we just wanted to see, because as you see from chemists, they think that the reviewers should see things and that editors should see things. And we wanted to start with this pilot study to see actually, can a human eye see it? Okay. So, and of course, because medicine also has a lot of images, and we tested medical pharmacy, dental medicine students in our study. And if we see that there is really a lack, if we can't see these duplications, maybe we should look at interventions that have to be implemented so that we are more aware and that we can recognize this. So we did a survey of all the students at our school. So we have medical students in Croatian, we have medical studies in English, which are attended by students from all over Europe and the world. We have dental medicine students and we have pharmacy students. So it's quite a lot. And then having these different aspects of medicine and also different origin of students, so not only Croatian, but people who are, English, they come from a different environment. So we had a questionnaire with images, and we asked them, they were all in color, and we asked students to circle the duplications that they identified. There could be more. We got them pencils in different colors. And each image, there were, I think, 6, represented one or more of these duplication categories that I just explained. So they had to we had an example like this one and said, okay, you go now and look at these photographs, and then you try to discover the duplications. We didn't tell them, we said that each picture has at least one duplication, but we didn't tell them how many. Okay, so these were the examples. This was like task 2, where they had to look at, or this was a task 5, where they also had to circle whatever it is. So these were the answers. They are still asking us, we haven't finished the study, so we're disclosing answer, but we have regular mails from students. When are we going to know whether we were right? We want to know but as we're still collecting surveys, we are still keeping quiet on that. So we had in the sample, in these examples that we presented in the survey, we had a total of 21 duplications, but because some were also multiple occurrences of the same duplication, there was a maximum of 34 points. So 34 different types of duplications in a figure. And we analyzed the number of correctly, but also incorrectly. Maybe people are overzealous, maybe we see too much. And that's very important. And I'm professor of anatomy, so when you look at history-anatomy, we always learn that morphology, you shouldn't see too much and you shouldn't see too little, but just the right amount of morphology. And we also wanted to see, if it's different, if you're looking at a gel, or if it's a histological slide, okay? And this is just the survey participants. So far, we have almost 700 students. Okay, you see their mean age. This is a reflection of the medical studies in Croatia, where we've, since the Second World War, had a predominance of female students. So this is a gender bias, I must say, and you see their breakdown in different programs that we have. And we had only, I think, 9 students that didn't fill in this data. So when we looked at overall, they identified a median of 10 duplications out of 34. So not really a lot. But also they had instances of incorrect markings with a median of 2. Okay. So they were much better in finding duplications in gel images than in cell tissue images. As you see here, 30% for cell tissues images and 33% in gel images. And when you look at the reference, it was significant. When we looked at which of the images, so here you see all the images that we had, then you see that some of them were easy to, like a third example, everybody recognized what was duplicated. But then if you go, and especially if you go to quite kind of complex and plain and almost gray histological images, they were not very good at recognizing that. So this is just the identification that the last was most difficult. Nobody has solved correctly the last task, and the third was the easiest because everybody could see these duplications. And then we did a linear regression analysis to see what can predict a Hawkeye, somebody who can detect it. And we probably, because, we were now going to see whether it differs from gel images and histological images. We didn't, whatever we measured, so it's whether the study program, how old they are, whether they had previous experience, study year. We also compared, the first-year students to fifth-year students, thinking that maybe, with experience, they would get better. But the only predictor that we found was female gender. Although the effect size, it explained only like about 2% of the variance. So that means that there are many other factors that are involved in there. So in both categories, female students tended to be better, and no difference in their experience in working with this, because first-year students will have gross anatomy, but third-year students will see pathology slides, and they will continue seeing them. So experience doesn't show things. So in conclusion, an untrained human eye that doesn't have a good skill in detecting duplicate manipulations in digital images. We are now doing the same thing, asking their professors. So these are professors from the anatomy, histology department who work daily with such images, people from the immunology, lab research, people from pathology, to see whether they are, better. Maybe you have to train. So far, our preliminary, when I look at these things, they are not better. And they all complained about the last figure, and they said we couldn't do that. So we definitely need to better understand, maybe even, from a point of cognitive behavior, what is behind, seeing errors in science, at least at how it is published. This is just some references. And we have to think of how to address this, that we better see when something is wrong in a scientific paper. So thank you. And maybe we can replicate the study somewhere. If anybody's interested, please contact me.
And the question, do we have questions? I don't see any. So, oh yeah, there's one. Great.
Thanks for your presentation. Why choosing student for your study? Because the students are the less able to be judged.
A good point.
And why not target people working for journal or editor?
Okay. Well, there are practical and kind of theoretical reasons for that. Practical is that for us working at a university, students are a good population where you can get big numbers, because if you want to get a representative sample, you have to reach about 400 people, whether your target population is 1,000 or 10,000 or 10 million, when you come to 400, it's kind of representative. And we also wanted to have a kind of a baseline. This is an untrained human eye looking at something. And they are kind of in a profession where morphology is important. So they have, some inclination. They will probably be better than patients, perhaps. And as I said, we are now testing also professionals, scientists who work with such images on a daily basis to see whether whether the research experience is important. We also, as I said, test the students from the first year. They are completely naive. But then we have fifth-year medical students who are experienced in looking at these things, because they have to pass the exams from pathology, from histology, everywhere you see these things. So that is the reason. And because you have to start somewhere. We couldn't find studies that actually looked at human eye and image manipulation.
I wonder what is the consequence of this finding in a way, because I actually see these kind of activities as a very useful training activity. So I think for the students, I mean, I do similar things when I do training on research integrity, but I see it as a training. So basically the idea is that then the students become aware that these kind of things exist. And then they will learn, their eye might get better, and also they know that it exists. So when they read papers, they will look for these kind of things, probably.
Exactly, yeah.
So I see it as a very valuable training activity. But then, okay, they're not that good at finding it in the first place. But then, or do you think that maybe you can do a longitudinal study?
Yeah, sure. You have to start, you have to have a baseline, because we are thinking about how we can teach the students or researchers, PhD students, whatever, about getting better at detecting digital image manipulation. But you have to start from a baseline to first see, what is it around, and then this will help us. Obviously, you have to train differently for histological slides, and then for gels. Gels are much easier than histology. So this gave us an idea, and we are now planning, interventional studies to see whether it helps, and whether if we teach them, whether they will get better. So this is a tool also to assess the training, and we wanted to test it first.
So then, kind of linking with Fred's talk and with our project on error correction, I mean, then what do you want them to do? Like, let's say,
or to be better when they make images, because this is how they're going to learn how to do better images themselves.
Sure. So that this is their production of science. So we would hope that they're not going to manipulate, or maybe they will learn to manipulate better so that they are not detected. But let's say you want them also to be critical reviewers through this practice.
Exactly. Yeah.
And so are you also going to tell them or discuss with them what they should do once they have detected malpractice?
I completely agree. I mean, one can make it into excellent educational experience. Find Waldo. I don't know if, especially people from the States, have this Find Waldo. This is these pictures where you have to find a tiny person in millions of other people. So this can be an exercise. We cannot all be Elizabeth Vick, but we can get better, and definitely it can help. But when you see what gets published, and I completely agree that editors really do have a role in getting all kinds of stuff published. For example, there is a colleague, David Waugh from Australia, who is a cancer researcher, but his hobby is catching statistical mistakes in Nature and Science. And he showed one picture from Cell, the journal Cell, and the author said, error bars in our graph represent averages plus minus means of 3 experiments. Averages plus minus means. It's the same thing. It should be average or mean plus minus standard deviation. And then you wonder, okay, maybe the authors don't know statistics, but reviewers didn't see it, editors didn't see it, copy editor, anybody in the whole production process didn't see something that, I would flunk a student on a research methodology course, a statistics course. And then you wonder, where are the tools for it that we know we are in a digital publishing and we still rely on, Word, and you send it in, you don't check anything, you don't even check whether your tables add up at the bottom of the row or column. Can you make some tool that they will automatically check, the totals in tables or something like that? I think we are lagging behind the development in technology in a way. But this is rambling off the topic. Yeah, I think if we have time.
So thank you very much. I have just a short question. You mentioned there is a gender dimension, but you did not comment it. Can you?
I can't explain. Maybe women are better in looking at details. Evolutionary, women were always, when we orient ourselves. I mean, I'm professor of anatomy, so I like to look at evolutions. Women were selected to observe little things in the environment. Men were selected to go for, for animals and catch them, So it's complete. The brain is wired in a different way. We have better association connections between the two hemispheres. So that can all explain it, but that's going into neuroscience. Better, yeah.
Thanks a lot. Oh, we have one more.
So it is very interesting. I also think that this should be included in medical curriculum. Creating, awareness about research misconduct, then later on follow up with the principles of research integrity. So if this is also, they start at this baseline, early in their medical stage by telling them about research misconduct. And later, as they advance, they tell them about the principles of research integrity. Then by the time they graduate,
Hopefully. Thank you.
Thank you. Maybe you can consider to pick out the geniuses if you find some that really have like a quota of 30 of
Calling and saying, when can we know?
Yeah. So, okay, with that, I thank again all the speakers that we had today, and thanks for your many questions. And I think we conclude for today, and now you have the chance to look at more posters again, if you like. And that's it. Thanks again also to the online community. Thank you.